Topic 13, angle relationships in triangles. Starting off with the triangle sum theorem, which states that the sum of the measures of all the angles of a triangle is equal to 180 degrees. Meaning that if I have a triangle with angle measures A, B, and C, that means that the sum of angle A plus the sum plus angle B plus angle C is equal to 180 degrees. Let's take a look at this as an example. Find the value of x. I'm not given labeled angles and such that A, B, and C. However, I'm giving what the angles are equal to. So very generically, I know that angle A plus angle B plus angle C is equal to 180 degrees. I'm going to let this be angle A, this be angle B, and this be angle C. Writing that in, then we have 7x minus 9 plus 4x plus 2 plus 77 equals 180 degrees. From here down, we're just going to use our algebra skills to help us simplify. 11x plus 70 is equal to 180 degrees. 11x equals 110. So therefore, x is equal to 10. Next problem, find the values of x and y. In this particular triangle diagram, we should see that there are actually two separate triangles. We should see the triangle TQR as well as the triangle TRS. Usually when these diagrams get more complex, it's often helpful to simply look for the smaller pieces that make up the more complex diagram and go from there. That being said then, this blue triangle, which I've shaded in, actually has all three angle measures. So for my blue triangle, we can actually write a relationship that 32 degrees plus 78 degrees plus x degrees is equal to 180, meaning that x is equal to 70 degrees. For the other triangle, my red triangle, I don't actually know the third angle up in this upper corner. I don't actually know that, but I don't really need to, because if I focus in on this relationship at the very bottom of my screen, I'm going to go ahead and redraw that angle. I have angle Y, and I have angle 78. They are together on a straight line, which means that they are, from previous unit, supplementary angles. And supplementary angles we know add to 180 degrees. So in terms of solving this, y plus 78 degrees is equal to 180 degrees. So therefore, y is equal to 102 degrees. We see how supplementary angles kept creeping into this particular problem. In example 3, we will see another former angle pair show its ugly head again. If I take a look at example 3 and try to highlight my triangle in red here, in terms of interior angles, I actually only know 25 degrees initially, but I can help figure out the other two angles by first investigating the relationship, which I'm highlighting in green. My angle 140 and this blue angle that I've listed there, they are together supplementary. So that means that 140 degrees plus my blue angle equals 180, meaning that that interior blue angle then is equal to 40 degrees. Additionally, if I take a look at x plus 123, this angle is outside my triangle, but it is actually congruent to this angle inside of the triangle by the relationship of vertical angles happening there, which we know are congruent. So looking at my red triangle then, I now know all three angle measures. 25 degrees plus 40 degrees plus x plus 123 is equal to 180 degrees. Simply solving this down now, we would get a value of x is equal to -8, and that would be my answer. I would like to point out that x in this case is just a variable as opposed to being an actual degree angled measure, so we're allowed to get a negative value in this particular answer. Once again, vertical angles helping us solve this particular triangle example. Jumping to the top of page 2, external angles of a polygon. External angle of a polygon is an angle formed when a side of a polygon and an extension of the adjacent side. I've drawn 3 separate examples for you of what it looks like on a triangle. The very most basic is I have a side and an extension. This gap, this angle that I've created on the outside is an external angle. On my second example, we can actually see that I've drawn 3 external angles off of this triangle. And in my last example, I've drawn 2 external angles off of the same vertex point. You should recognize from our last example that these 2 angles that I've highlighted in yellow are vertical, so therefore they are congruent. This actually shows up on a couple SOL example problems, which is why I showed you this example here. In terms of a triangle, we have the external angle theorem. The way that I find the measure of this external angle is that it is equal to the sum of the measure of its 2 remote interior angles. So what that means is, if I wanted to find the measure of angle 1, I know that it is equal to the sum of angle A and angle C. Notice the positioning of angle A and angle C. They are remote interior angles, remote meaning they are farther away from the external angle. Let's take a look at 2 examples. If I wanted to find the measure of angle 1, angle 1 is an external angle. 1 is equal to the sum of the 2 remote interior angles, which is 75 and 45. Which gives me angle 1 is equal to 120 degrees. Next example, here I want to find the measure of angle 2. It's interior in this particular triangle. So 109 is my external angle, 109. I know that is equal to the sum of the 2 remote interiors, so 51 degrees, and this unknown angle 2, if I solve this one, angle 2 is equal to 58 degrees. Example 6 is a bit more complicated. Lots of stuff going on in this particular diagram. I'm going to go ahead and highlight the triangles that make up this diagram. We should see that we have this green triangle. We should see this purple triangle. And we should see this slim light blue triangle over here. Now, each of these triangles gives us information regarding the problem. The green triangle, actually, we know all 3 angle measures. 37 degrees plus 116 degrees plus A is equal to 180. I can quickly and efficiently come up with the answer of A is equal to 27 degrees. My purple triangle also has all the angle measures known. 48 degrees plus 74 degrees plus C is equal to 180 degrees, giving me that C is equal to 58 degrees. My blue triangle, I don't actually know all 3 interior angles, but I see that angle D is an exterior angle to the light blue triangle, meaning that angle D is equal to the sum of the 2 remote interior angles, which in this case is 16 plus 122. Again, this is coming from my light blue triangle, giving me a value of D is equal to 138. To find angle B, I'm instead going to focus on this diagram. I'm going to redraw it for us. We see that we are on a straight line. From that straight line, we have angle B. We have angle 74 degrees, and we have angle A, which we just found to be 27 degrees. All of these together are on that straight line, which means that they are supplementary, which means that B plus 74 plus 27 equals 180 degrees. When I simplify that down, solve it, B is equal to 79 degrees. 3 triangle theorems, interior, interior, exterior, and then supplementary angles helps us solve this problem. Last page, 3 examples, all SOL style questions. Question number 7 is simply a word problem. It's difficult because we have to draw our own picture. So I'm going to go ahead and draw a triangle. with an exterior angle coming off of it. In the word problem, it says the two remote interior angles are 37 and 62. So 37 and 62. I need to find the measure of the exterior angle, which I'm highlighting in green. Well, I know that the green angle is equal to the sum of the two remote interiors, so 62 plus 37, which equals 99. Lastly, if I wanted to find this interior angle, which I'm scribbling in red, I can add up all three sides equal to 180, or I know that the green angle and the red angle both form 180 degrees. So green plus the red equals 180 degrees. So in this case, my red angle then is going to be equal to 81 degrees. All right. Example 8 brings back the idea of parallel lines. BC is parallel to DE. So zooming in on the picture, I see that I have two parallel lines cut by a transversal, which I'm covering here in red. So if these are my two parallel lines and they're cut by this transversal, this angle of 57 here is also 57 here by alternate interior angles. Also know that it's equal to 54 degrees here due to this green 54 and this 54 being corresponding angles. And of course, this 54 and this 54 are vertical angles. In terms of solving my problem, then I want to figure out what the measure of angle x is. Well, zooming in on this situation, I see that I have a straight line with angle x degrees, 54 degrees, and 105 degrees. They are in fact supplementary, meaning that x plus 54 plus 105 equals 180 degrees. So x equals 21 degrees. Example 9 follows the same idea. I have two parallel lines cut by a transversal. This angle of 67 also shows up here due to corresponding angles. So now that I filled that in as 67, I see that this triangle in question has all the angle measures filled in. So I can use my triangle interior angle sum theorem, knowing that 67 plus 46 plus x is equal to 180 degrees, giving me x is equal to 67 degrees. We saw the idea of corresponding angles showing up in this particular problem. In our previous, we saw alternate interior and corresponding angles as well. Let's not forget those as we move forward and attempt these triangle angle relationship problems on our own. That's all for this today. We'll see you in class tomorrow.